Hello, can you hear me?
Yeah, there's. Hello,
Y-
ma'am.
your voice is too feeble for
I
me.
can't hear you.
Hey, same here. Your voice is too feeble for me. Can you hear me? Hello.
Just 1 second. Try to speak. Hello, ma'am.
Yeah, can you hear me?
1 second.
Can you hear? Am I
One.
audible?
Okay, can you hear me now?
I can hear you. How about you? Can you hear me?
Yeah. Yeah, I can hear you. I can hear you.
Okay, great. Where were we in the previous lesson?
Last time I believe we were on balancing equations.
You are good at balancing, so we have finished it off.
Oh yeah, we were
Then
on filtration processes.
I think we were doing something related to the atom, right?
The atomic structure.
Periodic table.
Yeah. Oh yeah, we started chemistry in school.
Wait, what topic?
Let me just check teams. Yeah, just 1 second. It won't take long.
Mhm.
See the size. Yeah. Yeah, this is ours. Yeah. Okay, so basically we were just going through the periodic table
Mm.
and yeah, let me get my book. 1 second.
Mm.
Yeah, chemical equations we started.
That we have finished off, right?
Yeah, I believe we have finished off. Then we were going through the periodic table, doing the ratio of elements,
Mm.
mixtures, compounds, and elements. Yeah, that's all we've gone through so far.
So, did they give you any syllabus or what they are going to cover this year? Have they given anything of that sort?
No, they haven't given a syllabus, but I believe there's some sort of portion.
Okay, they haven't given anything.
Yeah, but I do believe that this book is similar to what we were using
Hmm.
or studying.
So you do not know what the school is going to do.
No, I know. I'm just trying to find the book.
Okay. So we were doing the periodic table. If you
Yeah, I
okay,
found
I'll continue from there.
we were doing the periodic table, atoms, bonding, and molecules.
Okay.
Then,
Uh,
okay, yeah, we can continue. I'm sorry for wasting your time.
Not at all. Okay. If I take the periodic table, do you remember what groups are, what periods are?
Which is this one? If you take the periodic table, okay, I'll try drawing the shape. Yeah, wait 1 second. So it's usually going to be classified into multiple groups. One is going to be the alkali metals, alkali earth metals.
Mhm.
Then there's halogens and noble gases.
Okay, this is what we discussed. You can see this periodic table, right? We
Yeah,
discussed that there are 18 groups. So we call this as 1, 2, 3, 4, 5, 6, 7, 8. Basically, it should be 18, but in your GCSEs, this is how we consider. And these
yeah,
are the groups when you go from top to bottom. And then when you move from here to here, you have something called as periods. We said there are 7 periods and there are 18 groups basically. And the group 1 is called as alkali metals, group 2 is called as alkaline earth metals, group 7 is called as halogens, and group 8 is called as noble gases. This is what we
yeah.
discussed in the previous class, right? All of a sudden, from where did we? Okay, 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 okay. Any doubts here?
Oh, no doubts.
Okay, and the charges also we had mentioned, like group 1 has +1 charge. Do you remember that?
Yeah, we've actually gone through that.
Yeah. What are the charges?
So the top one is the mass number, and the below one is the atomic number.
Yeah, that's right. But apart from that,
Oh yeah, the valency increases from 1 to 8, and the charge from 1 to 3 increases. Then the
uh,
charges from 4 to group 0, from 4 to the noble gases group decrease.
huh? Okay. So what should I say
So
then?
basically, the metals lose electrons and the non-metals gain electrons.
If I say group 1, 2, 3, 4, 5, 6, 7, 8, what are their charges?
Group 1 is a charge of +1, Group 2 is a charge of +2, Group 3 is a charge of +3, Group
Uh,
4 is a charge of -4, Group 5 is a charge of -3, Group 6 has a charge of -2, Group 7 has a charge of -1, and noble gases has a charge of 0 since they don't react.
Correct. That's right.
Then what about the valency?
The valency is the group number. Group number is equal to number of valence electrons.
So the electrons in the outer shells.
Yes. So using the electronic configuration, you can locate the element in the periodic table as in, if I take the electronic configuration, um, yeah, I can take like this. If I have 17, if I put 2, 8, 7, that indicates the last number is the group number. And the commas that you are going to separate, that's equal to the period number. This is how we find out. Is this clear?
Yeah.
Okay.
Have we covered this?
Yes, I have mentioned this.
Okay.
That's what electronic structure is. Okay.
Yeah.
Do you know what exactly melting and the boiling points are?
Melting point is the point at which the element becomes a liquid. Boiling point is the point at which an element becomes a gas.
Okay, that's right. So
The
melting point is,
temperature.
yeah, the temperature it is the solid turns liquid, liquid turns to gases, boiling point. So if you are given with the melting point and the boiling point of substance, how do you identify what physical state the compound is in? Say for example, um, solid, liquid. If I give the melting point of the substance, below which it is going to exist as a solid. In between melting and the boiling points, it is going to be a liquid. Above this is going to be a gas. You should be aware of this. Is that clear?
Yeah, that is clear.
Okay. Shall we go ahead then?
Yeah, just give me a second to copy this down if I can. Yeah. Just give me a second, I'm copying it down. Yeah, you can continue.
Okay. Now, if I take a substance A, its melting point is equal to minus 75 degrees Celsius. Its boiling point is equal to 5 degrees Celsius. At room temperature, say 30 degrees Celsius. What is its physical state? Is it a solid or is it
Liquid.
a liquid or is it a gas?
It's gonna be a liquid
Why?
because the melting point is negative 75 degrees Celsius, the boiling point is 5 degrees Celsius. In between the melting and the boiling point, it is stated that it's gonna
Okay.
be a liquid. So it's 30 no, it's gonna be a gas actually. Sorry.
Yes. Yes. So this 30 comes over here. So it's a gas at this
Yeah.
temperature, right? Do you have any questions?
No.
Okay. So, and how do you get to, pure substance in the mixture, right? We have done this. Do you remember?
Yeah. Just 1 second. Yeah, you were saying.
What is pure?
Pure
Huh.
substances that only contain one element.
Okay, fine.
Or you can say elements. Mixtures are groups of elements or mixtures or both, but not chemically bonded.
Got it. Got it. That's right. Any doubts?
No.
Okay. Shall we go ahead?
Yeah, you can go ahead.
Okay. Moving ahead. How do you determine a substance is pure or a mixture? You have to determine its boiling point as well as its melting point.
Yeah.
Okay.
Okay.
Say, if I'm taking any substance, if it is pure or the impure, you will have to know. So, if I take the heat I'm going to provide and the temperature, the amount of heat I provide and the temperature, if you take a scale, let's consider I'm going to heat a substance. Let's consider this is 0 degrees Celsius. I'll take it for water. At 0 degrees Celsius, it's ice. It's a solid. I slowly heat it. The temperature rises. Okay. So there is some point, not so 0. Let us consider this is minus 20 degrees Celsius.
Oh
What
yeah,
is
it has
in
to
the form?
stop for a certain time.
Sorry?
The temperature.
Huh? Did you say
And
something?
after
Sorry, the
that,
voice broke off in the middle.
the internet connection's unstable.
Okay. You were saying something. Can you come back, please?
Let me see.
I mean, your internet is not stable or my
Yeah,
internet is
mine is
stable?
good now. Mine is good now. So
Okay.
as the melting point as the temperature increases, it's gonna stop at a certain time and be the same temperature for a while.
Okay, it's going to
And after
stay.
that, the temperature is gonna go back and increase.
Let's consider this is 0 degrees Celsius. When it comes to 0 degrees Celsius, here until here it was a solid ice. Now it comes to 0 degrees Celsius. Okay. Then you increase the temperature again, and then when it reaches 100 degrees Celsius, again it stays same for some time, and above this is gonna be a gas. This is a liquid. Do you understand?
Yeah.
Any doubts here?
Oh no.
Shall we go ahead?
Yeah.
Okay. So this is solid, this is liquid, this is a gas.
Yeah. So
Now,
basically, if it doesn't have a sharp boiling point or melting point, it is not a pure substance or mixture.
yeah.
So that's it. I'll just write
Okay.
that down.
If it's a, this is for pure water, this is boiling and the melting point. If it is impure, then we will have something like this.
So a substance or a mixture is pure if it has a sharp melting point or boiling point. Is that correct?
Yes.
Just wait.
Okay.
Yeah, I'm finished. You can
Okay.
move on.
Okay. This is the next one. The first graph is for pure substance. This is for impure or a mixture.
Aren't mixtures not supposed to be pure?
Yeah, they are not.
So then I just have to write a substance is pure if it does have a sharp melting point.
If it is a sharp melting point, it is pure. If it is a range of melting point and the boiling point, then it could be a mixture or an impure substance.
Okay. Yeah, you can move on.
Shall we go ahead then? This is how you
Yeah.
identify. Then this is about a pure and impure substances. Then going back to the periodic table. Okay. So we have metals and the non-metals. What are these?
Yeah, just one sec. Yeah, metals and non-metals, they're classified into different categories, but then the main ones which can distinct them is that metals are sonorous, they are lustrous,
1 second. They
then
are generally hard
yeah,
and
they're hard.
they are brittle. Why are they brittle? What do you mean by brittle?
No, non-metals are brittle. Metals are usually ductile, aren't they?
Okay.
They are hard, they are ductile, they conduct electricity and heat,
Huh?
then it's sonorous,
Huh?
it's shiny, then
Huh?
it has a low boiling point, I think, and a high melting point.
Okay, it's hard and brittle, that's fine. The second one is if you consider the non-metal, they are soft, and here most of them are solids. Here they are soft and
Yeah,
they
but then if you
are,
cut lithium, yeah, but then during a practical when my teacher cut lithium, it was soft to cut.
yeah, we have exceptions everywhere. I'm generalizing. We'll come to the exceptions later. Soft, these can exist as gas or liquids are major. You rarely see solids over here. Okay. Then, in case of metals, uh, these are, we can say,
Non-metals can be solid as well.
yes.
So, okay. Good conductors of heat and electricity. They are ductile. Or conductors of heat and electricity, which means that they are a good insulator.
Yeah. But we have exception, that's graphite, which is a conductor. Okay. These have high melting point and high boiling point, whereas these have low boiling point and the melting points.
Yeah, should I write this down?
Yeah, you can. Or I'll finish it off, then you can write down. Okay,
Yeah, sure.
metals are malleable and ductile. You can stretch them, you can bend them, whereas these are non-malleable.
Oh yeah,
Uh,
metals are also sonorous.
yeah, non-ductile. We can say sonorous. These are non-sonorous. But you have exceptions everywhere. Group 1 and 2, they are soft, they are non-sonorous. They are non-malleable, non-ductile.
So, okay, I'll just write this down.
Yes.
Okay. Aren't non-metals supposed to be brittle?
Hmm?
Aren't
Why?
non-metals supposed to be brittle?
Yeah.
Then why'd you put brittle on the metals?
Metals are brittle, non-metals are not.
Okay, wait 1 second. Yeah, no, most metals are not brittle. They are generally malleable and ductile.
Hmm. Correct. Most metals are malleable and ductile, whereas non-metals are non-malleable and ductile. But when we say malleable and ductile and so hard everything, we have to leave
Yeah,
group
but then
1
when
and
I
2.
googled it, it said no, most metals are not brittle.
Most metals are not.
Brittle.
Yeah, it depends. Like we are saying, all have exceptions. We are generalizing. What most of them do, we generalize it.
So I can just put maybe brittle.
Maybe doesn't give the certainty. We generally say the proper things and then say, okay, these are exceptions.
Hmm. Just wait 1 second. I'll just copy everything down. Okay, I've finished it. Wait, what about group 1 and 2? You told.
If you are asked to write the differences, you can just code this. If you about group and one and two, we are going to study them separately. Okay, then
No,
we are going
what
to say
is
how
different about group 1 and 2? You told they are soft,
they
they
are
are not
soft.
grippy,
They can be cut using knife. That they are that soft. They have low melting and boiling points.
low bell, no melting and boiling point.
They are non-malleable, non-ductile. They are non-sonorous.
They are not sonar, they are non-malleable and non-ductile,
Mm.
but they do conduct electricity, right?
They will conduct because they are solids. You cannot connect them directly because they are soft solids.
Okay, non-malleable and non-ductile, and they are non-sonorous. So basically, it just violates every single property except the good conductors part.
Yes. Anyways, we do not check their conductivity. They are of no practical use.
Hmm. Yeah, okay. So we can move on. Are there any exceptions for non-metal? Oh, yeah, graphite conducts both heat and electricity, right?
Yeah.
Yeah, we can move on.
Any doubts?
Yeah, no doubts.
Okay. When we look at the periodic table, we have group 1 elements as well as we have transition elements. You know where their places, these transition elements?
Right in the middle of the periodic table
Exactly.
between group 2 and 3.
Okay, you see there are some differences between group 1 and 2 and transition elements. Group 1 elements are soft, whereas these are hard. These are less dense, like they float on water. These are denser, they sink in water.
So group one you told less dense, right?
Huh.
Yeah, okay. Yeah, you can continue.
Okay. So they are less dense, float in water, sink in water. That's right. The next one. In case of group 1 elements, we see that they have a fixed charge of plus 1. These have the variable charges.
Wait 1 second. But doesn't group one have a charge of plus one and group two has a charge of plus two?
Group 1 is plus 1, group 2 is plus 2. They have a fixed charge. Anything you take from group 1, that will have plus 1 charge. But in case of
So
transition element, it's not like that. For example, iron can have plus 2 plus 3. Manganese can have plus 2 plus 4 plus 6 plus 7. So their charges can vary.
yeah. So that depending on the type of group, for the group one to
Uh,
two, for group one element,
uh,
they have a fixed charge. Okay. अच्छा ठीक है. Variable charge. Variable charges.
okay.
Would you write for MN
Manganese.
-1 plus 2
Where negative 1? I showed an arrow. Sorry. It's an arrow. Plus 2 plus 4 plus 6 plus 7.
plus 2 plus 4 plus 6 plus 7
Mhm.
and Fe has a charge of plus 2 or plus 3.
Yeah, you need not remember the charges. You should remember that they have the variable charges.
Yeah,
Is this
you
clear?
can.
Then the group, there are certain features of transition elements. If you are asked, that I am putting star. This can act like catalyst. You know catalyst, right? Which speed up
Yeah.
the reaction. There's a special feature of transition elements, and they form the colored ions or compounds. Whereas these form non-colored compounds, like their solutions are colorless. So, for example, you take table salt, that is colorless, white, it's white in color. But if you take anything of transition elements, they are colored.
So for transition metals, they are catalysts and they form colored ions or compounds, whereas they
Yes,
form non-colored compounds, right?
yes.
Yeah, continue.
Is this clear? You can see some of the
Yeah,
compound transition elements.
yeah, potassium. Yeah, they both are diverse colors.
Yeah, they have different colors. Is that clear?
Yeah, that's clear.
Okay. How do the group 1 elements react? What are the special features? As I
They
said,
are
they
very
form,
reactive.
they are highly reactive, and that's why they are stored in oil or kerosene.
Okay.
Okay. The third one, they react with air and they tarnish. Tarnish in the sense when they are exposed to air, they change their colors.
So they react with air and water.
Huh. They react with anything and everything, like air, they react with water, they react with acids. The reaction with acids are explosive in nature. So
So
you
you can
should
just add air, water, or anything.
acid.
So just air, water, and acids. Do you put
Yeah.
that? Okay.
You do not have more than that in your curriculum.
What's the explosive part next to acids?
So with the acids, their reactions are very, very explosive.
So with air they tarnish, with water and acids they explode.
Yes. Only okay. I think we have done it with air. These these form corresponding group 1 metal.
Hmm.
Oxygen, they form corresponding oxides.
Yeah.
Group 1 metal with water, they form corresponding hydroxide plus hydrogen gas might be given off. With acids, they give corresponding salts plus hydrogen gases given off.
Yeah.
Is this clear?
Yeah, that's clear.
Okay.
Wait, let me just write that down.
Okay.
All of group ones are metals, right?
Hmm.
Oxide. Acids. Wait, with salts they form chloride, right? Like something chloride.
Hmm.
Okay. So can I just put chloride plus H2? Can
Huh?
I? Can I put chloride plus H2 instead of salt plus H2?
Yeah, if you use hydrochloric acid, you can write that.
Only hydrochloric acid. Yeah, move on.
Shall we go ahead?
Yeah, you can go ahead.
Then, how do you write its reaction? Like take sodium, write its reaction with air, water, and some acid, and give me the balanced equation.
For what?
Take sodium, write its reaction with air, oxygen, and acid, and give me the
Air,
balanced.
oxygen, and acid.
Yeah, the three mentioned that I
Sodium
mentioned.
plus oxygen equals to sodium oxide sodium plus water, sodium hydroxide, yeah, and acid, right?
Hmm.
Should I put HCl or what?
And you can put anything, any acid.
Okay. Sodium chloride. Yeah. Should I just type it in?
No, you can just, yeah, you can do that.
Okay. 1 sodium plus oxygen. Yeah.
The equation, balanced equation.
Oh, balanced. Ah, shit. Okay. I spent all the time writing for nothing. Na. Wait. I need new video. Yeah, Na. So Na is a charge of +1. O2. They cross. Okay, wait, let me just rewrite these. Na. Ah, how do I find this? I can't. I have to do typing. Oh my god. I'm using my mouse, so don't blame me. Na plus Na1 H2O. Okay, this one is difficult actually. Does oxygen just exit the equation for number 2?
Sorry, oxygen?
Exits the equation for number 2.
Yeah. Oh, I didn't get your question. Does oxygen, sorry, what did you say? Does oxygen
Exit the equation for number two.
exit? Why? Hydrogen goes off. Why would oxygen go?
Sodium hydroxide. H2. Okay, I'll try doing the last one. Okay. Wait, what? One second. My bad. Yeah.
Correct. That's right. Yeah. This is about the equations and the balancing. You're clear with it, right?
Yeah, I'm clear with that.
Okay. I will.
Okay, wait.
You have to. Okay. Where did it go? Like whatever I had written, that's also gone. It's okay. You just delete it, not an issue. Delete whatever you have written. I will save this and I'll share it with you. I have another class to go now.
Okay.
1 second. Um, okay. We will meet in the next week.
Yeah.
Okay. Okay then. Bye.
Yeah, bye.